Question 1. Area bounded by the curve y is equal to log x, x-axis and the ordinates x is equal to 1, comma x is equal to 2 is. There are four options where A. log 4 square units, B. log 4 plus 1 square units, C. log 4 minus 1 square units, D. none of this. Given curve y is equal to log x and x is equal to 1, x is equal to 2. Hence, required area can be given as 1 to 2 log x dx, that is integral 1 to 2 log x dx. We solve this, we get x log x minus of x 1 to 2. Substituting the value of limits in x, we get 2 log 2 minus of 1. Therefore, solving log, that is 2 raised to 2, will be 4 minus of 1 square units, which is option C. Option C is the correct answer. Question 2. The area of a region bounded by the ellipse x square by 9 plus y square by 4 equal to 1 is. We have four options, that is A 36 pi, B 36 pi upon 5, C 6 pi and D, that is 6 pi square. Area of ellipse x square by a square plus y square by b square is equal to 1 is pi AB. Here A is equal to 3 and B is equal to 2. Therefore, area of given ellipse is 6 pi, which is option C. Option C is the correct answer. Question 3. Area bounded by the curve y is equal to x into e raised to x square, x-axis and the ordinates x is equal to 0, x is equal to a is. We have four options: A e raised to a square plus 1 by 2 square units, B e raised to a square minus 1 by 2 square units, C e raised to a square plus 1 square units, D e raised to a square minus 1 square units. Required area is integral 0 comma a y dx, where we can substitute y value as 0 to a x into e raised to x square dx. We substitute x square as t, differentiating both the side, we get x dx equal to dt upon 2, where we get new limits as x is equal to 0, for t will be equal to 0, and for x is equal to a, t is equal to a square. Therefore required area 1 by 2 0 a square e raised to t dt half e raised to t 0 to a square. Substituting the value of limits in t, we get e raised to a square minus of 1 upon 2 square units, which is option B. Option B is the correct answer. Question 4. Area bounded by the curve x into y is equal to c, x-axis between x is equal to 1, x is equal to 4 is. We have four options, that is A c log 3 square units, B 2 log c square units, C 2c log 2 square units and D 2c log 5 square units. We have x comma y is equal to c. We shift x to right hand side, will get as c upon x. So the required area the limits are x is equal to 1 to x is equal to 4, that will be 1 to 4 y dx. So we substitute the value of y that will be c upon x dx. We take c as a constant that is outside. 1 to 4, 1 by x dx. So integrating 1 by x, we get 2c log 2 square units. Integrating 1 by x will be give you as log x. So substituting the value of limits 1 and 4 in the x, we get 2c log 2 square units, which is option C. Option C is the correct answer. Question 5. Area bounded by the curve y is equal to k sin x between x is equal to pi and x is equal to 2 pi is a 2k square units, b 0, c k square upon 2 square units, and d k square units. Required area is equal to pi to 2 pi y dx. We substitute the value of y, we get pi 2 pi k sin x dx equal to k. We take constant out of the integral, we get k to 2 pi sin x dx. We get integral of sin x, we get as minus cos x, which is pi to 2 pi. We substitute the value of limits in x, we get, and we solve, we get minus 2k, which is where we can say area cannot be counted minus 2. So we take minus 2k as area is equal to 2k square units, because area cannot be in minus. So the answer option A is a correct answer, that is 2k square units. Question 6. Area bounded by the curve y is equal to x cube, x axis and the ordinates x is equal to 1 and x is equal to 4 is. There are 4 options: A 64 square units, B 27 square units, C 127 by 4 square units, and D 255 by 4 square units. Required area is equal to 1 to 4 y dx. We substitute the value of y, that is 1 to 4 x cube dx. We integrate x cube, so we get x raised to 4 upon 4, that is 1 to 4. So substituting the value of limits in x, we get 255 upon 4, that is square units, which is option D. Option D is correct answer. Question 7. The area of the region bounded by x square is equal to y minus 2, y is equal to 4, comma y is equal to 6, and the y-axis in the first quadrant is. There are 4 options: A 2 comma 3, B 2 comma 3 bracket 8 minus root 2, C 2 comma 3 bracket 8 minus 2 into root 2, D 3 comma 2 bracket 8 minus root 2. We solve the equation x square minus 2, taking the root on both the side, we get y minus 2 root x is equal to y minus 2. Now therefore the required area will be 4 to 6, that is 4 to 6 root y minus 2 dy. Taking integration of root y minus 2, we get bracket y minus 2 3 by 2 6 4 to 6 equal to 2 comma 3. Substituting the value of limits in y, we get 4 3 comma 2 minus of 2 3 comma 2 3 raised to 2 raised to 3 upon 2, that is equal to 2 by 3 8 minus 2 root 2, which is option C. Option C is the correct answer. Question 8. Area bounded by parabola y square is equal to x and straight line 2y is equal to x is. We have 4 options: A 4 by 3, B 1, C 2 by 3, and D 1 by 3. We have y square is equal to x and 2y is equal to x. Y square is equal to x. If we see, we don't have limits in the questions. We can solve it as y square is equal to 2y. We substitute x as 2y over here. We get limits as 0 comma 2. So the new limits are 0 comma 2, and the equation for parabola will be y square minus of 2y. So the required area is equal to 0 to 2, that is the limit 0 to 2, y square minus of 2y dy. Integrating the term, we get y raised to 3 upon 3 minus of y square 0 to 2. Substituting the value of limits in y, we get 4 by 3 square units, which is option A. Option A is the correct answer. Question 9. The area bounded by the parabola y square equal to 4ax, its axis and two ordinates x is equal to 4, x is equal to 9 is. Option A is 4a square, option B is 16a square, option C is 20a square, D 152 root a upon 3. We have equation that is y square is equal to 4ax and the limits are x is equal to 4 comma x is equal to 9. So the parabolic curve will be through x and y. So the limits are x is equal to 4 and x is equal to 9. So the shaded portion which we need to find is this, the limits between x is equal to 4 and x is equal to 9. The shaded area is equal to given formula as 2 raised to 2 into integrate 4 to 9, and the equation is 4ax dx, which we got from the equation of parabola, that is y square is equal to 4ax. So we integrate the root part, we get 4 into root a into 2 by 3 x 3 by 2 4 to 9. We see that as a 4 coming 4 as a root of 2, where 2 into 2 is 4. Root a as a constant which comes out the integral, remains x, that is root, which we get as 2 into 3, 2 upon 3 into x raised to 3 by 2, and the limits are 4 to 9. Solving this, substituting the value of limits in x, we get 152 root a by 3, which is option D. Option D is the correct answer. Question 10. The area under y is equal to 2x plus sin x between y is equal to 0, x is equal to 0 and x is equal to pi by 2. As we have 4 options, that is A pi square by 4 plus 1, B pi square by 4, C pi square minus 1 by 4, D pi square by 3 plus 1. We have required area equal to 0 to pi by 2, that is the limits of x, and the equation for y, that is 2x sin x of dx. Integration, we get x square cos x 0 to pi by 2. Substituting the value of limits in x, we get pi square by 4 minus cos pi by 2, which it minus 0 comma cos 0, which in 10 turns to pi square by 4 minus 0, 0 minus 1, which gives us pi square by 4 plus of 1, which is option A. Option A is the correct answer. Question 11. The area bounded by the curve y is equal to 4x minus x square, and the y and the x-axis is, we have 4 options: A 30 by 7 square units, B 31 by 7 square units, C 32 by 3 square units, and D 34 by 3 square units. If we see the we don't have the limits, so we solve for the limits. That is, for x-axis y is equal to 0, So we substitute the value of y in the equation. We get 4x minus of x square is equal to 0. We're taking x as a common. 4x minus of x, sorry, there it will be 4 minus x is equal to 0. So we get value as x is equal to 0 comma 4. These are the limits, that is 0 comma 4 first. So now for the required area will be limit integrate 0 to 4x minus of x square dx, integrating 4x square by 2 minus of x cube by 3 0 comma 0 to 4, substituting the value of limits in x and the x value, it will give you 32 64 by 3, that is equal to 32 upon 3 square units. That is option C. Option C is the correct answer. 12. The area of the region bounded by y square is equal to 4x, x is equal to 0, x is equal to 4, and the x-axis in the first quadrant is, we have 4 options: A 16, B 16 by 3, C 32, and D 32 by 3. We have equation as y square is equal to 4x. We solve this as y is equal to under root of 4x. We get as 2x. So we take the equation of y in the required area. So the required area is equal to integrate 0 to 4 2 root x dx. Integration of root x is 2 x 3 by 2 upon 3 by 2 0 to 4. We substitute the value of limits in x. We get 4 by 3, 4 raised to 3 by 2 minus of 0. So we get as 4 by 3 into 8 equal to 32 by 3, which is option D. Option D is the correct answer. Question 13. The area of region bounded by curve y is equal to x square and x is equal to y square is, we have 4 options: A 1 by 3, B 1 by 2, C 1 by 3, and D 3. The two parabola intersect at 0, 0 and 1, 1. So the required area, we have 2 points, that is 0, 0 and 1, 1. So the required area is equal to 0 to 1 under root of x minus of x square dx. We integrate this, we get 2x raised to 3 by 2 upon 3 minus of x cube upon 3 0 to 1. So we substitute the value of limits in x. We get 2 by 3 minus 1 by 3 equal to 1 by 3, which is option A. Option A is the correct answer. Question number 14. The area bounded by the curve y square is equal to 8x and the line x is equal to 2 is, there are 4 options: A 32 by 3 square units, B 23 by 3 square units, C 16 by 3 square units, and D 13 by 2 square units. We have y square is equal to 8x, that is nothing but y square is equal to 8 into 2. We know that x is equal to 2. So we substitute the value of x as 2 over here. So we get 16, where square root of 16 is plus or minus 4. So the points of intersection are 2, 4 and 2, minus 4. So the graph or the diagram, the parabola is to x and the region which is bounded is 2, 4, 2, minus 4, and area to be found So we take required area, that is 2 integral 0 to 2 root 8 into x dx. We integrate this part, we get 4 root 2 0 to 2 x half dx, making simplification, taking 8 root outside from the integral, we get 4 root 2. Now taking the integration of x raised to half will give you 4 root 2 x raised to 3 by 2, 3 by 2, 0 to 2 are the limits. Substituting the points of x, we get 8 into root 2 up by 3, that is 2 raised 2 into root 2 0, that is nothing but 32 upon 3 square units. That is option A. Option A is the correct answer. Question 15. The area bounded by y is equal to 1 plus 8 by x square and the ordinates are x is equal to 2 and x is equal to 4 is the four options A 2, B 4, C log 2 and D log 4. Required area is equal to integration, limits are 2 to 4, 1 plus 8 by x square, where we know the equation for y is 1 plus 8 by x square. We integrate with respect to dx, we get as x minus of 8 by x 2 to 4. We solve this, we substitute the limits in x, we get 4 minus 2 minus of 2 minus of 4, which is 2 plus 2 equal to 4, which is option B. Option B is the correct answer. Question 16. The area bounded by the curves y square minus x is equal to 0 and y minus x square is equal to 0 is, we have four options, that is A 7 by 3, B 1 by 3, C 5 by 3 and D 1. If we see y square minus of x is equal to 0, we can take any equation to make area bounded equation. So we take first equation as y square minus equal to 0, we shift x on right hand side, we get y square is equal to x, so we take square root, so we get y is equal to root x. We substitute the value of root x, we substitute the value of y in equation number 2, that is y minus x square, we get as root x minus of x square. So the new equation is root x minus x square for the area bounded, and the limits which can be found is 0 to 1. So we take required area is equal to integration 0 to 1 root x minus of x square with respect to dx. We integrate it, we get as x2 by 3 upon 3 by 2, sorry, this is 3 by 2 minus of x cube upon 3, 0 to 1 is equal to 1 by 3. So the answer is 1 by 3, which is option B. Option B is the correct answer. Question 17. The area of the region bounded by the x-axis and the curves defined by y is equal to tan x. We have limits, that is minus pi by 3, which is less than equal to x and which is less than equal to pi by 3 is. Options are A log root 2, B minus log root 2, C 2 log 2, D 0. Required area, which is 2 into integral of pi by 3, which we got limit from this point, tan x dx. Tan x, which is a region bounded, which is y is equal to tan x. We integrate tan x with respect to x, we get log sec x 0 to pi by 3, which is 2 log 2. So option C is the correct answer, which is 2 log 2. Question 18. Area bounded by the parabola y is equal to 4x square, comma y axis, and the lines y is equal to 1, comma y is equal to 4 is. There are four options, that is A 3 square units, B 7 by 5 square units, C 7 by 3 square units, and D none of this. We have required area, that is 1 to 4, that is the limits of 1 to 4 x with respect to dy. We solve the equation 4x square for x, that is x square is equal to y by 4, taking square root, we get root y upon 2. So the equation for x will be root y by 2. So we substitute the value of x in the integral, we get root y by 2 dy. We integrate, we get 1 by 2 into 2 by 3, that is y raised to 3 by 2, 1 to 4. So we substitute the value of limit in y, we get 7 by 3 square units, which is option number C. Option C is the correct answer. Question 19. Area bounded by the line y is equal to x, x is equal to minus 1, comma x is equal to 2, and x axis is option. There are four options: A 5 by 2 square units, B 3 by 2 square units, C half square units, and D none of this. If we plot the graph, if we take x is equal to minus 1, which is will be over here, that is x is equal to minus 1, and x is equal to 2, which will be plotted at the positive axis, and y is equal to x. If we make a line which passes these 2 points, we get the area which is bounded inside the point, that will be x is equal to minus 1 and x is equal to 2, where y is equal to x over here, and even points 1 comma 0, 2 comma 0. So the required area, which is integral minus 1 to 2 y dx, we take property, that is y dx plus of 0 to 2 y dx. We integrate this part and substitute the value of limit in y, and we get the value, that is 5 by 2 square units, where since minus 1 to 0 comma y is equal to minus x, so the option A is the correct answer. Question 20. The area of the region bounded by the ellipse 16x square plus 9y square is equal to 144 is A 8 pi, B 80 pi, C 20 pi, D 12 pi. We have equation x square plus 16x square plus 9y square is equal to 144. We divide 144 throughout, that is on both the side, we get x square upon 9 plus y square upon 16 equal to 1. That is dividing 144 on both the side. If we compare the equation with the standard ellipse equation, that is x square by a and y square by b equal to 1, we get a is equal to 9 and b is equal to 60. So required area, that is pi a b equal to, we substitute the value of a and b in this required area equation. Therefore we get 4 into 3 is 12 pi, which is option number D. Option number D is the correct answer. Question 21. Area under the curve y is equal to root 3x plus 4 between x is equal to 0 and x is equal to 4 is. Options are A 56 by 9 square units, B 64 by 9 square units, C 8 square units, D 112 upon 9 square units. Required area equal to 0 to 4, 3x plus 4 dx. So we integrate, we get 3x plus 4 raised to 3 by 2 into 3 by 2, 0 to 4. We substitute the value of limits in x, we get as 2 by 9 into 56, that is equal to 112 by 9 square units, which is option D. Option D is the correct answer. The ratio of the areas bounded by the curve y is equal to cos x and y is equal to cos 2x between x is equal to 0, x is equal to pi by 3 and x axis is. We have options A 2:1, B 1:1, C 1:2 and D 2:1. By looking at the option, we can say that we need to find the ratios of two areas, that is A1 is to A2. I can take A1 integral of pi by 3, that is a limit of cos x dx is equal to root 3 by 2. Same as A2 for 0 to pi by 3 cos 2x dx, which I get as root 3 by 4. Taking the ratios A1 upon A2, that is root 3 by 2, root 3 by 4, I get as 2:1. That is A1 is to A2, 2:1, which is option D. Option D is the correct answer. Question 23. If the area bounded by y is equal to 3x square minus 4x plus k, the x-axis and x is equal to 1 comma x is equal to 3 is 20 square units, then the value of k is, we have A as 2, B 3, C 5, D 7. We have equation, that is 3x square minus of 4x plus of k dx, that is integral of limit from 1 to 3. We have the value for area bounded, that is 20. So we integrate this equation, we get as x cube minus of 2x square plus of kx 1 to 3 equal to 20. We substitute the value of limit in x, we get as 27 minus of 18 plus of 3k minus of 1 minus 2 plus of k is equal to 20. So we get as 9 plus 3k plus of 1 minus of k is equal to 20. We solve this, we get 2k is equal to 10, that is k is equal to 5, which is option C. Option C is the correct answer. Question 24. The area between the curve y is equal to sine square x, comma x axis and the ordinates x is equal to 0 and x is equal to pi by 2 is, options are A pi by 2, B pi by 4, C pi by 8 and D pi. The required area is equal to 0 to pi by 2 sine square x dx. Limits are given 0 to pi by 2. We integrate, we use half angle formula for that, cos 2x by 2 of dx. We integrate this part, we get as pi half x 0 to pi by 2 minus 1 by 4 sine 2x 0 to pi by 2, that is nothing but equal to 4, which is option B. Option B is the correct answer. Question 25. Area of the region bounded by the curve y is equal to tan x, tangent drawn to the curve at x is equal to pi by 4 and the x-axis is, we have options A 1 by 4, B log root 2 plus 1 by 4, C log root 2 minus 1 by 4 and D log root 2. We draw a curve for tan x, that is which passes through the origin, and the tangent which passes by x-axis, that is pi by 4, will pass through this. That is pi by 4 comma 0, x is equal to pi by 4. So the area need to be find is this part, which is limit under pi by 4. So the limit will be 0 to pi by 4. The shaded area is integral 0 to pi by 4 tan x dx, that is log sec x 0 to pi by 4. We substitute the value of limit in x, we get log sec pi by 4 minus of log sec 0, which is equal to log of root 2 minus of log of 1, which we get as log root 2, which is option D. Option D is the correct answer. Question 26. The area between the curve y is equal to 4 plus 3x minus x square and x-axis is option A 125 by 6, B 125 by 3, C 125 by 2, and D none of this. We know that we don't have points for the area which has been bounded. We know that the area which is bounded, equation y is equal to 4 plus 3x minus x square is of x-axis, so we take y is equal to 0 and solving this we get an quadratic equation 3x minus x 0, which we substitute in equation. Solving this we get points as x is equal to minus 4 comma x is equal to minus 1 comma 4. So the required area in points, that is from integral 1 to 4 of 4 plus 3x minus x square, we solve this, we get as 125 by 6, which is option A. Option A is the correct answer. Question 27. The area between the parabola y is equal to x square and the line y is equal to x is. We have four options, that is A 1 by 6 square units, B 1 by 3 square units, C 1 by 2 square units, and D none of this. Given curve are y is equal to x square and y is equal to x. On solving we get x is equal to 0, x is equal to 1. So the required area for the point of x is equal to 0 to 1 of integral of x square minus of x dx, we integrate this, we get x cubed by 3, x square by 2 from 0 to 1, substituting the value of limit in x, we get 1 by 3 minus 1 by 2 is equal to 1 by 6 square units, which is option A. Option A is the correct answer. Question 29. The area of the region bounded by the parabola y is equal to 4x minus x square, the x-axis x is equal to 0 and x is equal to 2 is, we have four options, A 8 by 3, B 16 by 3, C 16 minus root 2 by 3, D 8 plus root 2 by 3. We have y is equal to 4x minus of x square, that is the limit x is equal to 0 to x is equal to 2. So we required area will be 0 to 2, 4x minus of x square dx. We integrate this, we get 2x square minus of x cube upon 3, 0 to 2. We substitute this value in x, we get 8 by 8 minus 8 by 3, which is equal to 16 minus 3, which is our option D. Option D is the correct answer. Question 30. The area enclosed by y is equal to 3x minus 5, where y is equal to 0, x is equal to 3, and x is equal to 5 is, we have four options, A 12 square units, B 13 square units, C 13 by 2 square units, and D 14 square units. Required area is equal to, we have limits, that is 3 to 5, and the equation 3x minus of 5 of dx. We integrate this, we get 3 by 2 x square by 325 minus of 5x 325. We we substitute the limits in x, we get as 3 by 2, 25 minus 9 minus of 5, 5 minus of 3. We solve this, we get 24 minus of 10, which is 14 square units, which is option D. Option D is the correct answer.